Welcome to Steady Die Casting Solution. Today we discuss how to choose an aluminum alloy for die casting. A frequent question we receive at Steady Die Casting Solution is what alloy should I use for my casting? Yes, this is an important question. The alloy utilized in your casting affect the final properties, function, and the price of your casting, as well as the life on your die cast tool. So here, there's a simple checklist to define the best alloy for your applications. So there are few questions which you have to answer and to get know the best alloy for your casting. So first is, will your casting experience wear from motion against another part? Will your casting experience temperature in excess of 500 degrees Fahrenheit during the use? Will your casting spend its life outside and be exposed to the water and salt? Does your casting need to be pressurized? And will your casting experience high loads and to be expected to function as a structural component? Will your casting require heat treating? If you answer no to all of these questions, then you should use an alloy in the family of 380. 383 alloy is ideal for several reasons. The first is it produces a casting with a very good mechanical properties that meet the requirement of most of the applications. It has the lowest per kg because its a chemical composition is very common to the secondary aluminum recycle stream. And the third reason is it's a very friendly alloy for the die caster as it fills cavity well, minimize soldering, and can be held at lower temperature than other alloy. On the other hand, if you answer yes to any of the questions I have asked to you, then a more specialized alloy should be considered. And we have broken down common application and their ideal alloys. So first we discuss alloys for high temperature and wear resistance casting. If your casting will experience high temperature and be used in a wear application, then B390 alloy is an excellent choice. Components such as engine cylinder, piston pump, pulleys, and brake system are produced with B390 alloy. B390 alloy is considered as a very good alloy because it's between 16 to 18% silicon. Molten aluminum because saturated with the silicon at 13%. The excess silicon forms crystal in the metal structure that function as a hard bearing material for wear and strengthen the casting at a high temperature. So B39 alloy is an excellent material in the correct application, but it has certain challenges. B390 alloy is difficult to machine. The primary silicon crystal will wear machining tools more quickly than a typical 380 family casting. It is important that the die caster understand how to handle the molten B390 alloy. Improper melt treatment result in a silicon crystal fusing together. If the crystal grow in excess of 150 microns, they cause significant machining tool wear, can even cause space riser in the casting. And the B390 alloy is a very aggressive on die cast tooling as well. The molten material must be held at temperature in excess of 1300 Fahrenheit. The higher temperature and free floating silicon crystal cause a significant wear to the die cast tooling. Cold chamber and the melting furnace. You can expect at least 20% less tooling life using B390 than you would experience with 380 alloy. This is the major difference between 380 family alloy and the B390 family alloys. So the second we discuss alloy for the corrosion resistance casting. Will your casting spend its life outside the need to resist corrosion? And the copper in aluminum die casting alloy reduce the corrosion resistance. So 360 alloy. Yes, please mind it. 360 alloy with only 0.6% copper is an excellent choice for casting with this kind of requirement. So marine component and the pumps are frequently produced from 360 alloy for this reason. The third one we will discuss here alloy for pressure tight applications casting. So 413 alloy. 413 alloy is the aluminum silicon eutectic alloy. This means it solidify over the narrowest range and of the die casting alloy. Aluminum casting solidification begin at the surface, as you know, and the process continues progressively inward towards the thermal center of the casting. The solidification front produce a sound skin that is a pressure tight. Since the alloy solidify in such a tight range, the pressure tight skin extend much deeper into the casting than other alloys. A casting produced from the 380 family can also be pressure tight if the casting is designed with this mind and the skin not removed by the secondary machining process. So, moving ahead, we discuss structural alloy. So, new alloys have been developed which allow the die casting to be used for structural parts. For example, structural part are automotive body components such as shock mounts, door panels, and the engine carders. Structural alloy are also frequent found in the frames of the marine industry and off-road reaction industry. Structural casting will experience high mechanical load during that can be welded or riveted assemblies. So, iron is a necessary impurity in aluminum die casting alloy as it prevents the aluminum from the soldering to die steel during the casting process. A structural alloy replaces iron with the magnets and the strontium to prevent soldering. Removing the iron significantly increases the mechanical property of the alloy, allowing it to be used structural applications. Alloy play an important role in the overall cost and the performance of your die cast tool. We developed our checklist to assist you in choosing the right alloy. However, it's important to speak with your die caster about your casting specific requirement in order to determine the best alloy of your application. So here we discuss in a brief how you can choose your aluminum alloy for your die casting. So I hope it will help you. Thank you very much. Goodbye. Keep learning till then.